Welcome all to my ninth lecture. In this lecture, we will try to understand the different sections of memory using the final generated map file. So I'll try to take the example from the previous lecture. So if you do not watch my previous lectures, I highly recommend you to watch my previous lectures, which will lay down the foundations of the whole process. So when you try to create the project, you can see in the build, you can see we are ticking this particular option, generate make files automatically, right? So once you tick it, automatically a make file will be generated inside the debug. If you try to open this make file, we can see the compiler what you are using for pre-processing, compiling and linking, and finally generating the .out file. You can also see, like, the moment you put the source files, then you don't want to, like our in VS Code, when we made our own make file, we were giving the individually the source file names, but in this here, the moment you put the source file and the source file, if it is builded, automatically the source files are is a part of the make. Then you can see, like, what is the final output you need. So this .out.x files also will be generated. So let's try to take an example. So I have created this project in my previous lecture. So what I'll do is I have both my files. One is the flash linker command file. Another one is the RAM linker command file. I'll try to exclude the flash linker command file to start with, exclude from the build. Then I'll try to build the project. So the moment you build, you can see it will generate the map file, the .out file to the latest timestamp. I'll try to open the map file in the from the project environment itself. So here I'm opening the map file. So first let's try to see the global variable definitions, what we have created. We have created the structures, and then we have created some instances. So maybe let's try to start or check for the GPIO, which is like, which was we have in the previous lectures, we have tried to explain in detail about the GPIO part. So I'll try to copy this. GPIO control rex is the instance what we create. So if you try to see this GPIO control rex in the .map file, so we can see the GPU control rex. So we can see it's coming in 7C00, right? Now, if you try to open the non-bios.cmd file, you can see the GPU control, it should start with 7C00. So whatever the variable or the name you have given will get generated or will get aligned under this particular name, right? So, so in the same way, you can see the all different global variables what we have created. We have given a hash pragma a particular memory section, and then we have assigned this memory section into one particular zone using non-bias.cmd. So finally, you can verify this with the help of the map file, right? So now let's try to take the example of each sections. So maybe to start with .text, we will check with the generic RAM linker command file. So if you see, open the linker command file, RAM linker command file, we are saying that the .text will be a part of RAM ls0 and RAM ls1. So let's try to understand what will come in the .text file. So if you try to search the .text, we can see the .text it starts with 800. That is the starting portion, because we have given in the linker command file it should be ls0 to ls1. So it will start with 800 and then it finishes up at like say 9ff8. So that is the portion where we should be able to see the .text file. So if you try to see this particular area, what will be there in that particular area, we can see the functions whatever we have created. For example, we have created integrator function, integrator current, such things are created. So if you try to search this integrator function in the map file, so you can see this 807E, 8107. So these are the portions of the RAM file or the RAM LS0, because this is what we have given in the linker command file. Now, in the same way, when you try to exclude this particular file, and then when you try to take the flash linker command file, I just take right click, exclude from build. So now this will get included. Now, when I'll try to build the project, now you can see the map file. If I try to search the same integrator function, you can see now it is part of 8207E. So which is nothing but which is a part of the flash memory, because 8 to 15. So if you see 8 to 15, it starts with 8200. So you can very well see the location of these functions, integrator current and integrator function. So what is the understanding of the .text for RAM and flash linker command files? The function names will get stored in the .text memory. So if you try to see what is there in a .text memory, it is nothing but the function names. For the RAM linker command file, the .text will be placed in the RAM so that the program will not work once you switch off and switch on the power. So because the RAM is a volatile memory, when you try to place your .text file into the RAM section, the program will not get started, right? Or you cannot, none of the functions will be called, because it is lost because of the switch off and switch on. Again, if you want to start make the programming work, then again you want to reflash your code. So that is the use of RAM linker command file. But when it comes to flash linker command file, the flash linker command file, the .text will be placed in flash so that the program will start working even after power interruptions. So if you have the functions, if you place in the flash memory, so no need to again flash the code, automatically the functions, like as per the, like the flow of the program, each and every functions will be called and your program will work. So normally when you want to have a uninterrupted, or if you want to make your program a self-independent one, you will use the flash linker command file and you'll place your functions, everything which will after the compilation will be a part of .text, and this .text will be placed in the flash memory. So I hope you got some good understanding about the .text file. Now we will talk about the .cinit, the initialized global / static variables. So what is like .cinit .data? So if you see the .data section is for EABI format, so it's like you can also generate your program with .elf format. I'm not going to details. What we are trying to generate is .outfile. So as we are generating the .outfile, the global initialized variables will be .cinit. And if the program have to work properly, the initialized global variables should be stored in the flash memory. So let's assume that you have some global variables. So maybe in our example, we have some A var or B var. Let's try to give some value. So it's A var and B var. So this is nothing but a global initialized values, right? this A var and B var. So once this is compiled, this particular of global variables will get loaded or will be converted into .c init, and then you can see the .c init has to be assigned to the flash memory. It should be assigned to the flash memory. So if you are not assigned to the flash memory, the global variables value, whatever which we really want to store, like if you are storing in the RAM linker command file, it will get, it will get erased basically. So that is the purpose of the .cinit file should be a part of the flash linker command, or it should be the portion of the flash memory portion, right? But if you try to check this particular variables, so if you try to check this uh, global variables after in the map file, you can see something very interesting. So I'll try to show you this here. So now you can see, but this is coming somewhere into the 8000, so which is nothing but your RAM location, right? So you can see this A var and B var is coming to the RAM location. So the reason behind this is during the startup, after the code start, it will call some boot.asm file. So in the boot.asm file, this .cinit files, this .cinit for all the examples provided by TI, or when you try to use the same type of project setup environment, in the boot.asm, if you try to check the boot.asm file, it will copy the global initialized variables to RAM after the startup. So that is the reason why you are able to see the global initialized variables in the RAM, because this is basically to speed up the portion of the code, right? So this is nothing but the .cinit and .data section. .stack is the local variables which are stored on the stack on the runtime. So if you try to check some local variables, so maybe you can take any of the examples provided by TI like CCS, or when you try to create some like local variable, let's say set local, you cannot see this local variables in your in your map file, because the reason is it is temporary in nature. Whenever required, then only it will assign this particular memory portion, and then once it is used, it will again replace with some other local variables. So that is the reason why you cannot see the local variables in the .map file. Then when you try to talk about the .const, so the .const variables which are to be constant throughout the program. Normally, when we declare these variables as global variables, normally, like you can use this variable as global variables also, right? But there will be some purpose why you want to use instead const, because at starting, like when you just before we had seen, like when you have a global variable, it will get stored into RAM. So the RAM usage will be more. And also there is some accident by which the variables are modifiable. But the moment when you try to use the .const, you can see this .const, like it will not be a part of RAM at all. It will be a part of the flash itself. So maybe let's try to, give this const to this A variable. So now you can see the A variable will be a part of your flash memory, right? So let's try to, now you can see this, I think, both when you try to give like this, I think it took both A and B as const. So maybe I'll try to do in this way. Then you can see one variable will be RAM and another variable will be in flash. So let's try to verify that again. When you try to check this, when you try to check this, yeah, you can see the like A variable 880, it is a part of flash, and B, which is a part of RAM. So that is the meaning of dot const, because the dot const you really want to memorize, and you are putting, that is the reason why we are putting the dot const to the flash memory section. And the last portion, what I want to talk about is the uninitialized global and static variables. So that is nothing but will get, once you compile, it will be a part of .ebss section. So these variables are normally initialized to 0 at static and stored typically in the RAM memory. We'll try to check this as well. So when I tried, not to initialize this, uh, like like this a var, so now it will be a uninitialized global variable a var. Now when I try to open this, now it's coming to some RAM, because we have given this particular section .ebss under RAM also. So that is the reason why you are able to see the .ebss section into the RAM file. So I hope this was an interesting lecture and you got some insightful knowledge on the key memory sections of the code. See you all in the next lecture. Thank you.